Long term, what impacts does exercise actually have on the body? And just a couple of things before we get sort of into the nitty gritty of this. In my mind, I'm talking about adaptations, okay? These are long term training effects as a result of taking part in exercise for a long period of time. I'm talking about months and years of doing this. So these are examples, obviously they're static images, but we're assuming that this person here has been taking part in table tennis for some period of time, which hopefully is a fair assumption, and so on and so on. Now, before we get into the real sort of weeds of this, I want to categorize. I'm going to talk to you about training adaptations, so adaptations that will influence training. They're quite practical, really. I want to talk about skeletal adaptations, changes that happen to or in the skeleton. I want to talk to you about muscular. I'll put them down here. These are just headings at the moment, guys. Muscular adaptations. I want to talk to you about cardiac or heart adaptations. Probably should have done that one in red, really, but never mind. I want to talk to you about vascular. Why that would make this green, I don't know. Now, vascular adaptations. Vascular is the blood and the blood vessels, so we're going to talk about those. And finally, what have I not used? A bit of blue. We're going to talk about respiratory adaptations, okay? So that's what I'm going to take you through. And it's a nice model to be able to differentiate what each of these sort of adaptations sort of falls into. But anyway, let's start with this training one. These are quite general in many ways. Little bullet points. Let's do it this way. Basically speaking, once we are taking part in exercise regularly, we can train longer. Now, this relates to the time of fit, for example, okay? But we can also train with more intensity, and this relates to the I of fit, of course. So train with more intensity. By fit, I mean the fit principle. I should have stressed that. And also, guys, we have a faster recovery. Now, faster recovery can be seen as a time factor, but because we recover faster from training, we also expect that probably we can train more frequently, the F of the fit principle. Now, let's look at skeletal. Hopefully I got the same pink here. I think I have. Okay, so skeletal adaptations. What changes long term? Well, we get an up arrow, an increase in bone density. Now, this density, what we're talking about here, thicker, more dense. That prevents diseases like osteoporosis or brittle bones long term, for example. It's really good for one's health. It also prevents things like stress fractures. It's really good for our health long term. Okay, so we get increased bone density. And we also get an up arrow in the strength of ligaments and tendons. Okay, ligaments. What's going on with my writing? And tendons. So with ligaments, this means that joints will be more stable because that's the role that a ligament plays. And with tendons, the increased strength of a tendon, it's not a muscular pull, but tendons transmit force from muscle to a bone. So if they become stronger, we can transmit more force to the bone itself. Now let's think about muscular adaptations, of which there are many, but we're only going to talk about one here. We are going to talk about muscular hypertrophy. Now, what do we mean by the word hypertrophy? Hypertrophy is the thickening, the increasing in size of the muscle. So let's think about, someone who's going to the gym regularly, and what might happen to the bicep in the upper arm. It will increase in its cross-sectional area. It will become thicker. It will hypertrophy. Let's have a look at cardiac. Have I got the right color here? I think so. Cardiac adaptations to do with the heart. Remember, we are talking about a decrease, down arrow, in resting heart rate. Wonderful. That's really positive news. Now, if we've got a lower resting heart rate, what that means is we've got a greater range of heart rates available for exercise. Wonderful. Now, heart rate will ultimately go down because we've got, what I'm going to come to in a moment, an increase in the size of the heart. Now, if you want to, you can use the word hypertrophy again with the size of the heart. It's the same concept. Now, as a result of this, we get an increase, up arrow, in resting stroke volume. Okay, so stroke volume at rest is greater than the quantity of blood leaving the heart per contraction goes up. Why? Because the heart is bigger and stronger. It can pump more blood, in effect. And as a result of this, guys, we get an increase in maximal. Cardiac output. And the reason this is important, remember, cardiac output is the quantity of blood leaving the heart per minute. But if that goes up, cardiac output, in maximal conditions, it means that when we are exercising hard, we can get more blood flow around the body, delivering nutrients to things like the working muscle. That's very, very positive. Now, let's think about vascular. Remember, blood and blood vessels we're talking about here. We're going to get an increase in an interesting word coming here in capillarization. Okay, so at, for example, your alveoli, but also at the muscle, we have the growth of a network of a greater number of capillaries. This is where gaseous exchange takes place, and therefore we get a greater exchange. Wonderful. We also get an increase in RBC in the blood, red blood cells in the blood. We get more of them as a result of training. So what does that mean? We have a greater oxygen carrying capacity. Now, there's a nice way of referring to this. It's not really on our course, but it's an increase in hematocrit. You might come across that word. I'm just mentioning it. Don't need to write it down. I'm just throwing it in. Now, we also get a decrease in resting blood pressure. Decrease in resting blood pressure. So our blood pressure is lower during rest. Now that, as a health effect, is really very positive. And finally, guys, we get an increase in the elasticity of certain blood vessels. Now, can you perhaps name which blood vessels this would be? An increased elasticity of arteries, particularly, and I've been asked to tell you, and veins. Now, veins are generally speaking under very low pressure. Okay, so just be aware of that. But arteries are under very high pressure, so an increased elasticity, they can cope with the greater pressure, and as a result of that, they become more efficient. So lastly, guys, I've put it all the way back up here at the top. I've got these respiratory adaptations. Let's see if we can go through those respiratory adaptations. I'm going to talk here about an increase in lung capacity. Okay, so we're able, because of stronger respiratory muscles, to draw more air into and push out of the lung. That allows us to ventilate the lung better. We actually develop and can reach more alveoli deeper in the lungs. That's wonderful. And guys, I've mentioned this one just a moment ago. We get an increase in strength of our respiratory muscles. Now, which muscles could we refer to? Well, I'm talking about of the diaphragm, the diaphragm, we don't pronounce the G, of course, and the intercostals, okay, the muscles between the ribs. And if you want to be super accurate, okay, you could talk, in this case, about the external, well, I don't know about super accurate, you could talk about the external intercostals, and those are the ones that are involved with breathing in, okay? So we breathe in greater, deeper quantities, a greater quantity of air, greater lung capacity because of its increased strength of the diaphragm and the external intercostal muscles between the ribs. Those are our long-term effects of exercise.